Okay, CANDI update, kind of an update from where we were last year. We reported on some of this stuff last year. I want to acknowledge my co-conspirators in this. Paul Bowden, who was going to originally present this whole session that Bob and I have tag teamed on, but was prevented from being here for personal reasons, which is very unfortunate. A number of other people have been contributors to this over the past year or two. We started this effort, I don't know, 18 months or so ago. And the whole idea here was we've got this really great interop program. Can we build on top of it and do something that delivers more value to the community as a whole? We're getting great mileage out of the interop program, but kind of motivated by the characteristics of OFI and the OFI WIG program that we've got now, it felt like there was an opportunity to expand on what we're doing there with the existing interop program to see if we could, add more value going forward. So we had this small team that started meeting, and actually it was 2015 sometime, to assess the potential for creating, more value. One of the things we were trying to do about this was reach out to a broader community. The interop program is largely focused on vendors. It's interoperability amongst hardware. We really wanted to sort of take a page from the OFA philosophy to kind of reach higher up the stack and see if we could deliver value to not just the vendors and the providers, but consumers and users, people going all the way up the stack. That was kind of the philosophical direction we were trying to take. And to do that, we came up with this. Let me go back. There was this 5-part proposal that we put forward last year, which we've begun to execute on. The 5 parts were, this notion of training. There was some learning that came out of our experiences with RDMA training. The notion of a provider compliance validation test, which is sort of equivalent to today's interop program, but in OFI terms as opposed to the existing program that we have. And then other things that we could do going forward to support code development and code deployment and even end user usage of these things. So that was kind of the 5-part program we had in mind. Very ambitious kind of a program. And we started here because it was the obvious thing to do. Let's start by looking at something about provider compliance validation as a way to start. Today, again, that's in the guise of interoperability between various vendors. We're not talking about interoperability here, we're talking about compliance, and I'll show why that is in just a second. There is a real distinction. Up to now in the OFA, we've never done any form of compliance testing. It's always been interoperability testing, and it appears as though there's a need to expand beyond just interoperability testing to include compliance. And I'll talk in a second about what that means. The other thing, and I didn't want to let this go by, I wanted to acknowledge the fact that there is thought about this going on. The notion that we wanted this 5-part program, which was, sort of large and grandiose, a lot of that was outside of the scope of the people working on this CANDI effort, but we identified it as an important need. We learned with verbs that it's better if you have training early rather than later. We put a lot of effort as an alliance into creating or enabling, if you will, a training business or industry around verbs. And that was a really great effort, produced really good results, except it came too late. We were a decade into the deployment of verbs before we came up with training. So the lesson was the smart thing to do is to think about training early in the development deployment cycle rather than late. So with the emergence of something like the OpenFabrics Interfaces project, it seemed wise if we could start thinking about providing training to people who wanted it to understand how to use this notion of libfabric early in the process rather than later. So those of us working on this CANDI thing have bucked that over to the executive working group and the board of directors for action to decide if they want to enable some sort of equivalent training. We'll see what happens with that. But for our part, we were focused on this provider compliance and validation part of it. The motivation for it was, as I said, it emerged from the libfabric program, which is really about transport independence. And if you think about it for a few minutes, and I laid this all out in great detail last year, so I won't cover that territory again this year. But if you think about it, there really is no notion of interoperability when you're talking about a libfabric kind of environment. There isn't a notion of a provider from vendor A that interoperates with a provider from vendor B. Generally speaking, the providers are fabric specific, so that you don't really think about multiple providers interoperating. But you do think about compliance. Does a given provider comply to something or other? So we had this idea, this notion that you really want to be sure that the design complies with the API. So what does compliance mean? It means you comply to some specification somewhere, and in this case, that specification is what's contained in the man pages. So there's sort of a fundamental difference between this notion of interoperability and this idea of compliance. We're focused here on compliance. And this is sort of what I was just getting at. There is a distinction between interoperability. Today we're talking about do two devices interoperate with each other, an important thing to verify for sure. But this is much more about an entire software stack going up. So it's really a compliance question, not an interoperability question. So the architecture is designed to support multiple providers. That's the way the whole thing works. And this notion that each provider supports, a particular fabric, and not only that, but it supports a particular set of features and functions associated with that particular fabric. There's no notion that there's a minimum set of features that any one provider has to support. You can sort of pick and choose the ones that any given provider, vendor chooses to pursue as a function of the markets that he thinks are of interest to him. So that kind of raises this question, if a provider supports some feature or other, is that feature implemented correctly, and does it work the way that a user would expect it to work? And that's the key thing. What we're providing here is a service to those who will ultimately consume these providers, use these providers, such that they have some assurance that if they're going to run their application over some provider, that provider will provide the service that they're expecting to receive. To do that, we thought a really good place to start would be with the existing fab tests that OFI-WIG has created to support the development of providers. So there's this whole infrastructure, you can find it on GitHub, called fab tests, which the provider vendors are using today as they develop their providers to verify that they are operating according to the way that the API is expected to work. As you might imagine from a bunch of developers who are busy writing code as fast as they can, that list of fab tests is not as rich and thick as it needs to be, and by no means does it cover every feature, function, and option that's out there. So our objective was to start with, here in compliance land now, was to start with fab tests as a good basis from which to begin, and then enrich that and turn that into a mechanism for verifying compliance to the man pages. Again, generally when you talk about compliance, you mean compliance of something to something, where that something is generally a spec. In this case, there is no such thing as a spec for libfabric. What there is a very rich set of man pages which are serving as the de facto specification. So as we began looking at leveraging the work that's been done with fab tests so far, of course, several issues arose right away, as you might expect. The most glaring being that there probably are not currently enough fab tests available to cover the entire range of the whole matrix of features, functions, and options that are provided by libfabric today. And even if those tests do exist and they're rich enough, there's really no guarantee that all the options for any particular endpoint type are actually exercised through the code paths. And beyond that, even if you did have this completely rich set of fab tests that exercised every possible feature and function, right now there's no alliance-wide mechanism for submitting a vendor provider to that test and verifying that in fact he executed the tests to support the functions that he said he was going to support. So those are kind of the problems we started dealing with. So here's what we've been doing so far. We began by the simple exercise, and I'm being very facetious about that, cataloging all the features, functions, and options that are available in the existing man pages that are described today. One of the ideas about libfabric to begin with was that it would be simple. And conceptually it is simple, but it's also extremely rich, which means that there's a very wide combination of endpoints that are supported, endpoint types, functions that are run across the endpoints in various combinations, and the options that are associated with them. It's a very rich matrix. And to my knowledge, no one had ever sat down and cataloged the entire set all in one place. So we started by doing that, and we pressed Sean into service here to help us with this and created a very large matrix, if you will, that shows every function that's defined in the man pages and then all of the options and features and flags that are associated with each one. And that all by itself was probably a worthwhile exercise if we did nothing more than that. And I'll show you a picture of that in just a second, give you the idea. The next was, and that was all in the service of trying to understand where did we need to augment the list of fab tests that exist today to be sure that we're covering any existing gaps. And then once we'd done that and we felt like we had a sense of what was covered and what wasn't covered, the next question was, for any given fab test, and you take the whole set of them together as a group, how many of these paths are we actually exercising? And how many different features, functions, and options are actually exercised and what is not being exercised? So we began a project that Bob Russell undertook to statically analyze the fab test to look and see what code paths even exist to verify and validate any given combination of a function, a flag, and an option to go along with it. That is a good and useful thing to be doing, and we're partway through that exercise, but even that's not sufficient because even though those code paths exist, there's no guarantee that there is a fab test that in a dynamic way actually exercises that code path. So the next step after that is going to be to dynamically analyze the fab test code paths to be sure that we really are exercising the entire universe of functions, features, and options. And then once that's all done, then the next question becomes, how do you certify any given provider against the resulting set of fab tests? So a provider says, it advertises, this is the set of functions that I support and the options and flags. How do we take that and test that against, our monster compliance test and say, yeah, you actually did what you said you were going to do? So that's the challenge that's in front of us. This is a snippet of that canonical list that I described. It's 700 lines, so I obviously didn't show you the whole thing, but I just wanted to give you a flavor for how it works. This is going to get posted to GitHub, probably in the wiki section, sometime in the not too distant future. But the way you read this chart is on the left-hand column all the way there are the references to the man pages. So for any given function described in the man page, there's a set of functions and structures associated with it. In this case, we're showing, get info, and a bunch of others that go along with it. And then for any given function or structure, there's almost always, a set of fields and parameters associated with it and options related to that. So it was kind of a long exercise to put the whole list together, but I think in the end worthwhile. The idea here is that as the program progresses, as we develop this thing, we're going to fill in the cells. You see across the top, I should back up just a step. Across the top is the set of endpoints that libfabric defines today. So the idea is that for each endpoint, we'll put a check mark in each box for if that that combination of feature functions and flags is applicable to that given endpoint. And that will give us a list of the combination of things that need to be tested. So this becomes the basis for defining the set of fab tests that we have to run to verify compliance with the man pages. Call to action here, we are short on fab tests. We're going to need some help creating more fab tests as time goes on to fill in the gaps. This is what happens after you run Bob Russell's preliminary static analysis program he's been working on. This is what happens when you run it. In this case, it was for a particular fab test called ping pong. And what you can see here is that there's nothing filled in most of the blue endpoints, and that's because the ping pong test doesn't exercise any of those types of endpoints. So you can see this is exactly the kind of thing we're looking for. If you ran this static analysis tool against the entire set of fab tests that exist today, we would hope that we would see more check marks in various boxes, the ones that are blue right now. Those need to all ultimately be filled in to say, yes, we've tested that combination. Or maybe that combination isn't valid. We'll find that out as well. So this one I said for a ping pong test, the Y here indicates that this fab test does in fact contain a code path that really exercises that combination of functions and options that goes along with it. But as I mentioned before, the fact that you do a static analysis and that such a code path exists doesn't mean that that code path is actually exercised in the real world. So the thing that we haven't grappled with yet is once we understand that, how do we go off and dynamically validate that the code paths are in fact actually being executed? So that's going to be the next step in our process. Another call to action here, we're looking for creative and interested people who can help us understand tools in order to do that sort of thing. We've got some ideas about it, but we're a fairly small group, and more insight would be more than welcome. Okay, I'm at the end now, which is good. I just wanted to raise the level of the discussion up just a little bit here. We've been focusing here on this compliance business, but we're really talking about, more than compliance testing. And if you think about, again, the way that the Interop program works, it delivers a lot of value primarily to the network hardware and software vendors. But sort of the OFA's larger mission, if you will, extends way beyond that. It goes way up the stack to that stuff that's currently grayed out. So what we're looking at here is what else can we do with this compliance program, or this whole expansion, if you will, to the Interop program that exists today, to deliver more value going up the stack. So my question to those in the audience is, we really do need to hear from people other than hardware and software vendors. When I say hardware and software vendors, I'm talking about device vendors now. We need to hear from people other than them and say, what kind of value could you get out of a program like this if we were to offer it? What can we do to expand it to deliver greater value to you as a consumer of OpenFabrics technologies? And that's what I had to say. Any questions? If there are, I'll endeavor to answer them. If not, I'll do something else.
A couple of questions and or comments.
Yep.
One, you had mentioned that in the OFI space that interoperability isn't necessarily the thing that you want to be testing, because they're really providers for a specific piece of hardware.
Right.
And that's true in most cases where you have, a provider for GNI or a provider for US NIC, but we do have at least one provider that does run over multiple types of hardware. That's the verbs provider. So you might also consider interoperability testing of OFI verbs provider using different RDMA Rocky devices or iWarp devices or InfiniBand devices.
That's an extremely good point. I thank you for mentioning that. I would point at this little note in the bottom right-hand corner that the OFI architecture, it doesn't require interoperability. It's not based on an interoperable model, but it also doesn't prevent it.
Right.
So to the extent that there are providers where that happens, we want to be able to support that. But we didn't want to lose sight of the fact that what we really need is to be sure that that verbs provider is in fact compliant with the
correct.
With
you
the
want
API.
to do both.
That's right.
And then the second comment, I guess, was around your statement around code coverage.
Yeah.
And making sure that you had code coverage. So one thing that you might investigate, there are various tools in the industry that actually allow you to measure code coverage. One of them, I think, is called Bullseye. It's being used in some projects internally in Intel for doing such things. And so you might, consider researching that space and see if there's any tools that could be utilized to help you with that.
Yeah, when we're looking into that sort of thing, the issue that comes up with that is, some very large percentage of the code has to do with error paths, as you would well know. And often when you run a code coverage tool, what you find out is that your coverage is abysmally small, because the majority of the code has to do with exercising paths that never get exercised. So I'm not adverse to that, but there is a downside to it.
Well, you have to realize that, maybe it comes up and it says you've got, 40% or something, and you're like, oh my God, I'm not testing all the code.
Right.
But it's because of the error paths. And then, you have to be careful that you don't actually put in extra code so that you can write a test to cause the code path to be exercised, with that extra code actually hurting your performance.
Right. You wind up putting checkers in to check the checkers.
Yeah. Right.
Yeah. And we need to keep an eye on the fact that we are not trying to put in some sort of a functional test or functional verification method. That's not what we're after. So we think that the vendors of providers should be doing that. They should be exercising their provider to make sure that it works in all error situations. That's their problem. We just want to be sure that it complies to whatever the API says it's going to do.
Hi there. I'm curious if there's a plan in place for after the fab tests get fleshed out and we have good coverage to make sure that we keep that coverage so that we don't just start adding more features and then letting the fab test slip and lose coverage.
That's a very good point, and there's a certain amount of discipline that's required to be sure that that doesn't happen. So far, the OFI program and OFIWIG in general has been pretty good about creating new fab tests, to test a new feature or function as it emerges. That's one of the values of the way that the OFE program works, is that because we meet every 2 weeks, we're talking about this stuff on a regular basis, more than just on a mailing list sort of thing. So the question can get asked, well, here's a new feature, how is that going to be tested? That being said, that sounds great. We're all humans, and we tend to want to charge ahead and work on the next feature. So some discipline is required to be sure that we keep the fab tests up to date.